So, good afternoon, everyone. Welcome to our monthly computational social science webinar organized by the Computational Social Science Lab at the Chinese University of Hong Kong. I'm an associate professor and also associate director of the lab. So today we are very, very happy to have Professor Yang Di here. So let me briefly introduce Professor Yang, and she's currently an assistant professor in the computer science department at Stanford University and also affiliated with the Stanford NLP group and HCI group and also the Stanford Human Center AI Institute. So I guess the audience here that know that she is a pioneer in large language models for computational social science. And she also won a lot of prestigious awards. So I guess here today, she will share some recent studies. And without further ado, so please join me to welcome Professor Yang. Okay. So during the talk, you can just post your questions in the chat box, and later we will pick some of the questions during the Q&A session. Okay. Uh, Professor Yang, welcome.
Yeah, thank you. Thank you so much for the very nice introduction. Can everyone see my screen? Okay, let's get started. Hi, I'm Dee. Today I'm very excited to share some of the recent work we have been working on around using large language models for computational social science. I want to start with some opportunities and then discuss challenges in this space. If you have any questions, feel free to use the chat or just unmute yourself. I want to start this talk by highlighting this pioneer work done by two researchers earlier around the community structures of political blocs back in 2004. So it's almost 20 years. It used network analysis and data from blog to visualize the link structure within the community of political blocs. And here, as you can see, the right dot, the right nodes here indicate conservative blocks. And then the blue one refers to liberal blocks. And then you also saw these orange links go from liberal to conservative, and then purple ones from conservative to liberal. This is a very interesting analysis, and it's a very classic example of computational social science research, where the goal is to collect and analyze data at a scale that may reveal patterns of individual or group behaviors. This is a definition from Lazar in around 2009. This is a very interesting definition. And I think also, if you think about what happens after 2000, the increasing usage of social media or online media largely facilitates computational social science research. And it also provides great opportunities for us to leverage large-scale data to study diverse CSS tasks in a wider range of domains. To share you a few representative tasks, this might include topics such as misinformation, hate speech, polarization, or researchers study online communities, mental health, social influence, social identity, or social movement, as well as a lot of societal challenges. Those data-driven work, they provide very insightful signals about social and cultural phenomena, as well as insights about the larger society. Not only just from a data or phenomena perspective, I think this also leads to a lot of very exciting technical work or methods that advance methods and approach for computational social science. Such as the task of sentiment analysis and opinion mining, which was very core to computational social science and also lead to a lot of advances in the natural language processing field. From a text analysis perspective, we can see that in addition to network analysis, you can perform agent-based simulations or utilizing causal inference. You can not only use text, but also audio or image from a multimodal approach aspect. There are also a lot of work looking at algorithm fairness infrastructure, intervention, and platforms. Similar to social science theories, I think those technical thrusts and also machine learning advances also provide a very strong foundation and toolkits that enable the modern computational social science research. So this is a very interesting space already. However, or especially with the recent rise of large language models since 2018, we saw that if you only look at NLP tasks on traditional NLP tasks, such as conversation chatbot or question answering or machine translation, those models are outperforming prior supervised machine learning methods. And they can also achieve almost the human level performance or even outperform average humans on many exams, such as the bar exam, which is a legal test, and also SAT, and many other tasks. To share with you about those capabilities in the context of computational social science, let's think about how we might use large language models related to, let's say, a nervous high school student applying for college. Large language models can be used to query people's mental mode of themselves, their environment. They can be used to infer individual differences, help people reappraisal stressful experience, simulate the personas, synthesize information from different places, and also try to simulate natural dialogue. So you can see that there are a lot of possibilities one can leverage large language models for. And the text or predictions were generated in seconds. So it's a very fast speed, which means that the large language models can accomplish a broader set of tasks relevant to computational social science very, very quickly. This is basically my thesis today. That is, large language models can help us unlock possibilities from a improved accuracy perspective, from an efficiency perspective, scalability, and also from a generation capability perspective. And I want to mention that many of those capabilities were unthinkable just a few years ago. If you think about several years ago, if we want to study online text or online social media data, we need to build supervised machine learning models. We need to collect a lot of data labeling and then build a machine learning classifier to scan them. Or we work with researchers to code them manually. Today, I think with only a few short examples, you can achieve very high prediction accuracy. In our recent work around using large language models in psychology, we basically categorize the potential use of large language models in computational social science into three aspects. The first dimension is what we call measurement. That is, whether we could use large language models to identify or measure construct, social construct in text. For example, we could try to predict emotions in text. The second dimension here is called experimentation. That is, maybe we can use large language models to generate stimuli and response for pilot studies. The last condition here is what I call intervention, which means that large language models can actually help users practice in simulated environment. I want to give you some examples from the recent studies to show you how those three dimensions can be operationalized. If you think about measurement, this is actually the most common usage of large language models in computational social science. From a measurement perspective, on my screen, this is actually an earlier work from OpenAI. They basically show that for very challenging tasks, such as content moderation, if you use GPT-4 to label whether a given text violates certain type of guidelines, the labeling quality by GPT-4 is similar to human moderators. And those moderators probably receive very lightweight training, which is the middle bar here. This is a pool B. However, both are still overperformed by experienced, well-trained human annotators. That is, if annotators or moderators have a lot of expertise, then they are still doing much better compared to existing models. To look at some other dimensions, one recent work also showed that large language models is capable of accurately detecting different type of psychological constructs as judged by like manual annotators. Those are signals in text that capture like anger, fear, sadness, sentiment, etc. And you can just use simple prompts. There is no need to obtain additional training data here. You can also think about large language models from an experimentation perspective. You can use it to study emerging social behaviors, or even generate a synthetic data set of large language model generated response in this kind of what people call humanless pilot experiment. So on the left part, this is a very popular study around the generative agents. That is, they set up a few, actually around 20 generative agents living in a village, and then try to study any emerging social behaviors there. And then on the right, researchers try to use GPT-3 to simulate how a certain participant might respond to a survey question. You can also use it to look at personalities. You can use it to estimate effect size or even conduct a power analysis. Researchers also use it to study different type of phenomena such as persuasion. And now you can actually look at how simulated participants might react to different versions of the same message as a way to test which one is more persuasive from a pilot study perspective. More importantly, I think for a long time, computational social science research used to only look at insights and the data. And recently, people are very excited about interventions. That is, how large language models can help enable the development of potential interventions to actually turn our analytical insights into working systems. On my screen, this is actually a recent study. They built an AI-based tool to improve online conversations about controversial topics. So here, instead of like a specific response, the AI is going to suggest the different ways of how the person should react. And then the user can actually pick any of them. And this might change the conversation for more pro-social outcomes. In the education domain, researchers also show that if you have this large language model-based feedback systems, we can actually use it to improve teachers' uptake of students' ideas, to give feedback to teachers. In this way, we can really open the door for many creative use of large language models in education. So those are very quick highlights or possible approach of large language models in the context of computational social science. In today's talk, I want to focus on just two aspects here, from a measurement perspective and then from an intervention perspective. From a measurement perspective, I want to share our recent work on can large language models transform computational social science. We analyze zero-shot performance of around 13 large language models on 24 representative tasks. And from an intervention perspective, I will talk about this social skill training with large language models by sharing with you how we can use large language models to teach conflict resolution skills through simulated practice. In the end, I will also talk about some concerns of using large language models in the social science domain, and then we can talk about how to deal with them moving forward. So let's get started. The first one, can large language model transform computational social science? So first, I want to acknowledge that social science is very broad. Given that it's very broad, we must identify some common tools. And if you think about what people use in computational social science, the first is around the supervised text classification. Social scientists train classifier on labeled data so that we can quickly scale up manual coding efforts and make inference about unlabeled text. And this annotation process require extensive labor and financial resources. And it may seem like more efficient to use unsupervised clustering or topic modeling, but then the resulting cluster or topics can be difficult to interpret. So if a large language model can give us very reliable labels without much supervision, or even in a semi-supervised manner, then CSS research could be broadened to a wider range of hypotheses that current tools and the data resources support. So to answer those kind of questions, we decided to evaluate large language models when they first came out. We look at extensive sets of CSS tasks, basically span from psychology to political science to literature, history, sociology, and linguistics. For each task, we basically identify a corresponding benchmark dataset. And I also want to mention that this is only a subset of the task. And there may be more tasks. So here, I'm trying to just give you some representative tasks. And we actually cover more in our research paper. As you can see for psychology, briefly, if you think about the social psychology, there may be tasks such as emotion recognition, humor recognition, politeness recognition. From a mental health well-being perspective, there may be empathy classification. If you look at the political science, people care about framing and ideology. We might have tasks such as issue frames extraction or ideology detection. When it comes to literature, there may be literacy analysis, narrative analysis. We want to understand the agent framing or relation dynamics among characters. In history, we care about how to extract the historical events. In sociology, people study power dynamics, such as power relation classification, or even social roles that people occupy in teamwork or just in everyday life. From a linguistic perspective, there are a lot of social linguistic variations, such as dialect identification. So as you can see, this is actually a wide range of tasks. And many of those tasks, they are not like new. And if you look at the different type of research field, not only in CSS, but also in natural language processing or machine learning, you can see that there are actually a lot of data set we can collect for each of the specific tasks here. So researchers have been building all sorts of data sets for those tasks. And then if we take a very closer look at them, some of those tasks, they are what we call utterance level. That is, in order to get the task solved, we only need to look at the information in that sentence. Some of them in this yellow color, they are conversation level. That is, we need to understand the conversation in order to infer the labels there. And those red boxes are what we call document level understanding. That is, we need to understand the entire document in order to figure out the relations or ground truths. So those are all tasks related to classification. We could also imagine that there are other type of tasks, such as generation. So for generation, here I just use some of them to give you a quick example. So we look at the figurative language explanation, implicit hate speech explanation, misinformation understanding, as well as positive reframing. So this one is related to emotion regulation. So as you can see, there are more and more tasks we can throw into this space. And once you take a very comprehensive view of all those different type of tasks, then we can ask a lot of research questions. From a model selection perspective, how does modern model architecture change or influence CSS task? From a domain utility perspective, are large language models better adapted for some subfield, such as sociology, than others? From a variability perspective, can large language model augment or even replace human annotations? From a functionality perspective, can they do coding and generation as well? So to answer those questions, this is in earlier this year. So we basically look at a lot of models here. From an autoregressive perspective, so we look at the GPT-3 and also GPT-4 here. We also look at the encoder-decoder architecture, FLAN T5, and many of the model variation here. So for some of them, we also can fine-tune with a small amount of data. So just to make a comparison here. This page is really hard to understand as it has so many numbers. But what I want to show you is this part is FLAN T5 model families, somewhat open source. And this red box is API-based models. So most of them are from the OpenAI family. Okay, so those are fine-tuned. So fine-tuned models here, we use Roberta as a comparison. So if you look at the specific cells here, when I highlighted them, it means that they are the best number across that row. And then more importantly, if we only care about model performance, this kind of fine-tuned version, like let's say you take a Roberta and then you fine-tune it on your training data, they can actually give you much better performance. Compared to we always say like, okay, maybe GPT-4 would solve everything, but you can see the performance contrast here. So again, this table was derived earlier this year. And very interestingly, if you look at what people care about from this model parameter size scaling perspective, what we see is that this FLAN T5 model performance, they actually follow this specific function. And for OpenAI models, we didn't observe patterns until only like, this is like GPT-3, and then also see this kind of decrease, a little bit of decrease when it comes to GPT-4 here. From a domain utility perspective, I think this is quite interesting, especially if people are from different research field. You might be wondering whether large language models are better adapted for some field of social science over others. So remember, we divided the task into like their respective field like this. But of course, we recognize that all tasks, they may have multidisciplinary utility. So this partition may not like best capture everything here. But we hope that this partition help us understand the academic scope of those systems. We found that there is not actually a strong bias against or favor any particular field of study. So performance is not tied to academic discipline. Instead, they are more about the complexity of the input. That is, if the task needs to involve document data type, document usually encode a complicated sequence of ideas or temporal events. And then overall, models may not be doing well there. And then compared to utterance or conversations are relatively simpler here. There is also another very interesting framing where when GPT-4 or 3 just came out, there are a lot of research talking about we do not need the crowdsourced platforms anymore, and the human annotators are using large language models. So the question here is, can large language models augment human annotation pipeline? If what we see from these papers, expected, then we would expect that large language models can actually serve as one of the potential labelers here. Then if we use them to do the data annotation and compare it with human annotation, we should be able to assess how well they agree with each other. So what we are going to do is we are going to just calculate the flexi-kappa agreement between the zero-shot model performance or model labels and the labels from human. So in this way, we can actually compare to what extent the human annotation are aligned with large language model annotation. I'm going to use this figure to show you the results. So x-axis is model accuracy, and the y-axis is the flexi-kappa. So basically, each of the dots just shows like what's the corresponding accuracy and what's the annotation agreement among large language models and humans. Each point here refers a specific task, such as emotion detection. Very interestingly, I think this plot basically shows that top performing large language models may be ready for some zero-shot classification task, such as emotion detection, stance, or misinformation detection. They all have F1 score larger than 7.0, and then flexi-kappa larger than like 0.5. And many of them even match the human kappas reported in the original paper. But then if you move this to the lower regime here, we still need a human in the loop for most tasks. So we only see like fair agreement among humor detection, power relations, politeness, and also implicit hate here. So for this like a very nuanced task, we saw that the agreement from large language models and human tend to drop, and then their accuracy is also not very high. And then if you keep moving to this regime, you saw that around 1/3 of the task, even the best models still show very, very poor annotation agreement with human annotations. And then those kappas are below 0.1 or like 0.15. So from this, I think we can conclude that today's large language model cannot be simply used as a replacement for human annotations, especially in this social science domain, given that many of those social signals are very nuanced and require human annotation. Hopefully, I shared with you that even the best large language models still show low performance on some CSS tasks here. We still need a kind of human in the validation loop to ensure the soundness of the findings and also to avoid replication crisis. So instead of like using large language models just as annotators, we actually recommend that CSS researchers use large language models with annotation. That is, you can actually use some co-annotation framework here. Think about you have some task. We're going to assign it to large language models if they can do it very well, and only assign it to humans when we cannot get a very reliable result from large language models. So in this way, we can actually achieve task allocation to models and then defer to experts for the most challenging scenarios. The last part here, I want to show you more about the generation capability here. Basically, what we did is for each of the specific tasks, we have experts looking at the generation or the response from GPT-4 models and then try to evaluate that. We look at those 5 tasks. We basically show that model performance, if we are going to like look at the human domain expert evaluators, they actually found that zero-shot GPT-4 models produce helpful and informative generations in all of those evaluation tasks. As I mentioned, we basically hire experts to do such annotations. And experts use a 1 to 5 Likert scale to score each data point. And again, if we map them into this 2-dimensional space, the x-axis here shows you human good reference best score, and then y-axis shows large language model best score. So in terms of faithfulness, as we can see, it's pretty high. And also relevance and coherence. So basically, zero-shot GPT-4 performance compared to a lot of the reported reference or ground truths we have in the dataset, they tend to be much better. Also, in a head-to-head kind of pairwise comparison, our expert evaluators also prefer GPT-4 generations over the human good reference, at least like 40% of the time. With all of those findings in mind, just to quickly summarize this first part. Basically, after we did this like a very comprehensive investigation of many models across different research fields in social science, I think one thing we do realize is that there is no systematic tendency for like certain higher or lower performance by subfield. And still it remains the responsibility of researchers to validate many of those specific results. And it's very important to do a cost-benefit analysis. On one side, we could benefit from the improved scalability, efficiency. On the other side, such annotation from large language models may not be very accurate. We could consider integrate large language models in the loop to transform large-scale data labeling. And also, if you remember the contrast between open source large language models and the API-based models, that's the performance were not significantly different. So we could also prioritize open source models for classification. From a challenge perspective, some kind of challenges I want to highlight here is especially when the taxonomy of social construct are very subtle or require expert knowledge, we found that models tend to struggle with them. And more importantly, when the size of the target label space is big enough, then models cannot figure out the dependency or hierarchical relations among those. And from a temporal grounding perspective, given that many CSS tasks probably need to require on temporal events, we found that such temporal understanding are still not as impressive compared to other dimensions. So this is the first part of the work. I'm going to quickly stop here just in case there are any clarification questions.
Channel has a
Oh, okay, cool. Yeah.
yeah.
Oh yeah, thanks for your presentation. Yeah. Could you go to the measurement part? Measurement part. Yeah, you have a page about the let me see. Using LLM in computational social science measurement about human ratings. Goes
Do you
up, yeah.
remember the page number?
Sorry, it's maybe at very first. Yes. My question is about the measurement. So here, the main method you mentioned is about human ratings. And you just use this size to tell us the GPT, the large language model can have a better performance about the human ratings. But my question is about in some research field like social or like psychology. Um, actually, we even we have human ratings, we don't know this concept is accurate. Just like we have a we have a question like do you think most people is trust? So here, when one person reads this question, uh, he will think, what does it mean the most people for me? So for the different people, they have different concerns about the most people. So the definition is totally different for the everybody. So I think when you are using the questionnaires to do this work in the real world, you cannot get the accurate response. So how could you know this human rating can get the accurate result? So this is my first question. The second question is about some definition about in the psychology is quite vague. We don't know the clear definition. We just use it like cooperation, like trust, like vulnerability. So we don't have a clear definition. How could we measure this kind of concept by using the computational method? So this is my second question. My third question is about the validity. Yes. So how just as I asked, we even cannot get a ground truth about the question in the real world. How could you know this work is accurate
Yeah,
by
I
the
think
language
those are
model?
all
Yeah.
excellent questions.
Yeah.
All great questions. First, for this specific page, this is about emotion, anger, fear, joy, sadness, sentiment. So y-axis is the scores given by GPT-4, and then x-axis is the human ratings. I would jump to your other questions later, but for this specific page, the measurement is actually on a few social constructs where we have clear understandings. So of course, like whether something count as sad, like whether a given text is sad or not, or contain sadness or not, might have variations from human to human. But for this like very basic emotions, I think the correlation or the agreement among humans are pretty high. So for this specific figure, I think it makes sense in a way that those are already like a well-validated social constructs, basic emotions. So the human ratings are probably just like the average of several different type of annotators, and then they are trying to do this kind of correlation. So the correlation here is like above 0.6. So this is like a Pearson correlation. So as you can imagine, this is already a very kind of strong measurement here. And then going back to the rest of your question, what you are really asking is, for many of the social constructs, humans have different understandings. I totally agree with that. I think this is a great kind of observation. And such variations might tell us a lot of things. First, it might be possible that your social construct was not very well defined. If you cannot well define it, your annotators will not agree very well on it. Second is, even it's well defined, you might still observe variations. This could mean that your annotation guideline is not clear. This could also mean that annotators may come from different background, people's cultural background, political background, or a lot of like social economical background may influence their interpretation or perception towards the social constructs. So you will see a lot of those variations. I also want to kind of comment that variations are not bad. Disagreement is not always something that we want to remove from the process. If for certain kind of social construct, you observe that actually we just have opposite findings if you use those two different type of annotators, then I think that means something new. So this kind of ratings or not agree with each other is not only like should not only be viewed as a like bad signal or whatever. I think it should be viewed from how we can better understand those variations. And last but not least, I think for the definition that you just shared around like trust or cooperation, I think those are all like very broad terms. Sometimes those terms are heavily loaded with different type of meanings. Specifically, when you have a concrete context or scenario, you may need to operationalize such trust in a specific domain. To give you one very quick example, we were looking at do people trust the email written by GPT-4 or GPT-3? Trust is such a giant term. We really cannot just ask people like, do you trust this more, etc. Instead, you may want to look at, okay, does people's like prior attitude towards computers change, like have any influence? Does their like prior understanding of AI change? How would they use it? Would they like recommend it to their friends, etc.? So I'm pretty sure there are a lot of such questionnaires to quantify specific dimension. So usually like how we approach it is, if this term is really broad and we don't have really good interpretation of it, we tend to break them down into very specific operationalization in that context. Sometimes such context specificity will bring in a lot of clarity into the definition process. I hope that answers some parts of your question.
Yeah, thanks. I got a lot.
Okay, I'm going to continue so we can finish this second part and then go back to all the questions. The second part is more from an intervention perspective, and this is some work we have been doing around the social skill training. Why do we want to do social skill training? So in addition to a lot of the computational social science research, I also care about how we can actually help people learn different type of subjects, such as learn math, learn coding, etc. And I also have this recent passion towards how we can actually help people learn soft skills, because it's actually really hard to learn these soft skills. It's very time consuming, it's expensive, it's limited in availability, psychologically unsafe. And also, if people don't have enough social network or social capital, they might be in disadvantaged positions to learn those social skills. So large language models can actually enable interactive and personalized training that transform learning in many unthinkable ways. This is actually a framework that we introduced this year called AI Partner and AI Mentor. The key idea here is that a learner can actually learn with an AI partner and coached by an AI mentor. AI partner is large language model empowered agent who users can practice with for different topics. And AI mentor is large language model empowered agent who can provide feedback to help users improve their skills. So let's say you have a user who want to learn a skill such as conflict resolution. This user is going to practice with AI partner, and the process is going to be coached or facilitated by an AI mentor here. This framework can actually be utilized in many, many different domains. In education, users could be teachers in training, and the AI partner could be virtual student. AI mentor could be experienced teacher, and teachers in training can actually learn how to better manage classroom. In negotiation context, users could be first-generation students, and AI partner could be simulated HR, AI mentor could be career counselor, and students can actually learn active listening, persuasion, how to advocate for themselves. I want to give you a quick example of conflict resolution. So this is a system we build where we teach people how to navigate conflicts here. So on the right part, you saw this conversation where this person seems quite angry and they want to return or they are going to talk to like someone's manager. And the conversation can go into this like power stage where this person probably is going to reply with, "Can you watch your tone?" Versus if you take a different type of conversation response, it might go into a very different outcome. So the key idea here is that we are going to simulate those realistic conflicts and allow people to explore counterfactual here. In this way, we can teach conflict resolution through deliberative practice. One very quick question here is that why do we want to teach conflict resolution? Well, conflicts is pervasive, and conflict resolution strategies are also kind of like a well-studied in management science or in business school context. However, today's like conflict resolution learning or training is still limited to static material. So if I share you the task of simulating realistic conflict, something you are very likely to do is you probably are going to just like use large language models to simulate an angry person, because those models are trained on a lot of internet data. Maybe they have looked at some conflicts before. So you would expect this going to generate conflict simulations. However, there are a lot of failure mode if you just use the off-the-shelf large language models to simulate the conflict. The first one is that we are very likely to get a simulation that's very cooperative. In this case, the simulation from the language model, they like agree with people too quickly and make the practice not very effective. So whatever you try, the language model is going to agree with you. On the other side, we can get a simulation that's very stubborn. So the language model will never agree with you. Both of the simulations are going to be ineffective. So in this condition, regardless of what you try, the simulation still stays very angry. So what we actually want is actually something in between, a language model that when we use the right strategies, they can give us or they can agree with us in the right time. And in this way, you can get some implicit feedback that using the right strategies will result in the right outcome. So how do we do this? We basically merge expert theory using this framework called interest, rights, and power from conflict resolution literature. And we merge them into a prompting pipeline. So by merging this theory into prompts, we can actually generate better simulations and provide some counterfactuals. So in this pipeline, there are two phases. In the plan phase, we basically use the conflict theory to constrain the language model generations to only generating strategies related to the IRP framework here. And then for each of the generated response, we are actually going to score or rank them in terms of how likely this message will result in a heated conflict or result in like some reduced conflicts. And then we can add back those selected messages to the conversation context and then repeat to simulate the conflict. From an ecological validity perspective, we want to make sure that our method makes sense. So we compared the two different conditions here by giving the resulting simulations to human and let humans select which one is better. So across our experiment, we found that using the full pipeline I just mentioned actually can lead to significant better performance compared to if you just prompting ChatGPT. So let's walk through a simulated chat with rehearsal system. So on the top of the interface, we'll give you the situation and the role of a conflict. And we can either like use this scenario crafted by an expert, or we can let someone else define their own. So in this example, we are going to role play the manager, Casey here, who needs to find out why their employee, Jerry's attitude has taken a turn for the worse. So the employee simulated the Jerry just started by asking, why are we having this conversation? So this is from Jerry here. And now like we could just write our own message here if we want to. Or we could look at the potential counterfactuals that rehearsal generated. So instead of what I wrote here, the system will also recommend what you could do here. And here is an example of rights where the generated message talk about the standards and the norms. So in this message, I highlight how Jerry isn't meet the expectation of their job. If we just click the fast forward button, we can project the conversation into the future and then see how Jerry's simulation might react to this specific message. So if we let the conversation evolve, we can see that this message actually does not look like a great reaction. So by trying the strategy grounded in theory, I can actually practice the theory and see the effects. Or here, let's just do the same thing, but with a different strategy here. And this strategy asks the participant about their interest and how might we help. And if we use this strategy, we saw that we get a much more reasonable response from Jerry. So it looked like we are making progress. Then I can click continue and keep interacting with rehearsal. To evaluate this type of systems, we did a user study where we recruit 40 people who want to learn conflict resolution. And we give them all static training materials from a conflict resolution course at Stanford. And we also give them like a video walking them through about the interface. Once we have that stage done, 20 people go directly to the final evaluation, and another 20 people practice with rehearsal for 25 minutes. And then in the end, we let them do a quiz to assess their knowledge. We also let them to do an aided conflict with the researcher here. To make the story simpler, we are going to divide all the interest-based strategies into what we call cooperative, and then rights power-based strategies as what we call competitive or aggressive. In this kind of like researcher conflicts interactive evaluation, we found that there is actually a significant increase in the use of cooperative strategies. So basically, participants can double their use of interest-based messages. And we also saw a significant reduction in rights or aggressive strategies here. So participants basically reduce their use of competitive strategies by around 60%. Very interestingly, what we found is that this kind of systems actually does not significantly improve knowledge skills compared to the control condition. That is, if you quantify people's learned knowledge, we actually didn't see any differences here. So this is actually very interesting. So we did a further investigation, and here is what we found out. Basically, while both the static training and the rehearsal improve like book smarts, only rehearsal improve what we call like street smarts. That is how you actually use those strategies in context. So it is not about whether whether the system help people remember the definition of conflict resolution better or worse. It's more about this kind of systems provide an interactive channel for people to practice such usage here. This get further echoed by our participants. As you can see, many of them mentioned that it's easy to read about the conflict resolution strategies, but a lot harder to implement and stick to them. Just to kind of quickly summarize this part, rehearsal is quite effective because we basically ground this conflict resolution theory into the process and use it to build the model generations. We also realized and found out from our study that this kind of systems does not work for everyone. There was one participant mentioned that I felt like the training helped me learn new methods, but I'm stubborn by nature. And once the person was rude from the beginning, I did not want them to get their way. So this is definitely a personalization dimension that future work needs to investigate. The next example I want to quickly share is actually about the therapy. Where if you think about this kind of skill training, we can also use similar framework to help train counselors with large language models. Especially like during COVID, I think many of us have seen this increased mental health concerns from a lot of friends or family members or just like people around. And unfortunately, there has been a severe and worsening mental health workforce shortage. If you look at how counselors are trained, what we found is that traditional approach, such as role play, does not scale. So I want to give you a conversation just to show you how we can actually use AI to help with this process. Let's think about Jane here. Jane is a seeker with mental health concerns, and she's talking to Alex, who is a novice counselor here. So Jane said, "I'm so stressed, it's overwhelming." And Alex, without a lot of training, could respond with, "Sounds really bad." And if at this moment we have an AI mentor, as I mentioned earlier, the AI mentor could help diagnose which skill Alex could use, provide suggestions, and maybe highlight example response here. With all of those, Alex might rewrite as, "Sounds like you are going through a challenging time. Can you tell me more?" So now instead of Jane here as a single person, we could have many, many different type of Jane here. So Jane is our like AI partner here. From a technical aspect, there are actually several technical challenges. First is there might be unrealistic simulations. In fact, what we found is that the simulation are either too cooperative or too stubborn, as I showed earlier. And 20% response generated by GPT-4 are not realistic or appropriate. And the simulation might also produce caricature that amplify biases here. On the other side, if you look at AI mentor, we also found that they may produce very generic feedback. Those feedback are not very faithful to the given input. And sometimes they violate therapy guidelines because models or large language models, they are trained to be helpful to solve problems, while in the context of therapy, the goal is to be there and listen. To deal with this kind of unrealistic simulation, we basically co-design with domain experts. And we are going to set up this thing called constitutional AI for therapy. So the key idea here is that if we have a conversation between the therapist and a patient, so the patient here is AI. As you can see, the patient, this AI patient is not responding in a very realistic fashion. Well, how do we know that? If we give this conversation to an expert, the expert may criticize this AI patient's feedback. So we are going to collect a lot of this natural language feedback and then induce or infer a few principles from it. So the principle here, such as when someone gives you encouraging words, you respond with hesitancy, double the significance of that positive perspective. Because in practice, patients never say yes so easily. So this is not a very realistic simulation. When we collect a lot of those feedback, we can then use those feedback to update the generation of response from our AI patient. So in this kind of constitutional AI framework, we saw that the AI patient we created actually rated as more realistic by counselor themselves. They are going to be more authentic. They can stay in the role. They can resemble past case. They can mirror very challenging aspect. And people also think that they are ready as training partners and would recommend to other novel counselors. We also give this to like third-party counselors. As we can see, such effectiveness still remain similar. Not only just from a AI patient perspective, if you think about building an AI mentor here, we actually, again, work with domain experts and then design this framework to give feedback. So we will highlight what is the goal or alignment, point out areas for improvement, as well as give them some goal-aligned response here. The method that we introduce is actually a self-improvement framework. So imagine you already have a model, and you can use this model to generate many different types of response for this given context. And some of the response might be good, some of the response may be bad. And then you are going to get those like synthetic preference pairs and then use the existing like preference tuning method to make it work. Our method actually works pretty well compared to existing approach. As you can see, this self-improved conditions actually lead to response being rated as good or very good by domain experts. I'm going to show you a demo. So this system right now actually incorporates both the AI patient and AI mentor framework. If you cannot hear the video, let me know. Okay. Okay, I will just talk about this. So this is a system users can actually log in and they can practice with different patient here. So here we select a patient with social anxiety, and we can chat with this AI patient here, and we can type a response and continue the discussion. Once we are done, we can click this review feedback on the top corner here. And this is our AI mentor. And AI mentor will tell us where we did well and what areas we could use some feedback. And then we will also give you some specific response here. So as this, in this way, the person can actually learn by looking at those different type of feedback. So this system right now is used by the School of Medicine at Stanford. So first year psychotherapy students actually learn counseling skills by practicing with this AI patient and get a feedback from AI mentor compared to like very classic textbook. We also invited around 40 counselors to try out the system. And as many of them mentioned that this type of system present a very immersive environment. And they found AI patient give them very challenging and diverse practice. And our AI coach are very constructive and helpful and help people, especially in terms of self-reflection and learning. So just to quickly reflect on this part, I think what we learned is putting together a working human AI collaboration system is actually not trivial. And we haven't looked at a lot of the long-term impact on people's skill acquisition. And the broader question I want to share here is how we can actually make those evaluation useful, because a lot of the model development work look at benchmarks or data set or offline data set that we collected. But if we want to build interventions and care about the real world use, there always seems to be a gap. So it's very critical to think about how we could actually mitigate the gap here a little bit. So this is the two work that I want to share today. So the first part I talk about, can large language models transform CSS? And then second part, I talk about social skill training with large language models. To conclude this a little bit, I think the benefits of using large language models in computational social science is it helps us with improved accuracy, efficiency, scalability, and the generation capabilities. It will also help us with a sandbox so that we can conduct analysis and create interactive interventions. There are concerns of using large language models in CSS, specifically from an evaluation perspective, because evaluation is really hard and the standard evaluation are very different. If you think about expert evaluation, which is something that social scientists use a lot, where we rely on third-party assessment. And this might suffer from like subjectivity, or sometimes there is no right answer. From impact evaluation perspective, I think it's very important to think about how we can actually look at the effect of large language models or on some kind of utility dimension here. This part could be really hard to understand because interventions may not always change certain outcomes. So when the intervention failed or didn't achieve what we are looking for, it becomes really ambiguous to interpret what happens. We briefly talk about this like reliability versus validity here, especially given that a lot of the study we want to use large language models for around measurement. So it is really critical to think about the validity aspect, how well the test really mirrors the construct or the concept it was designed to evaluate. And there are also other dimensions of validity, such as like face validity or criteria validity here. From a bias or harm perspective, I think large language model generations could actually introduce or amplify a lot of the harms. And some of them may be related to representational harms. Some of them might be related to sampling biases, etc. One of the study we recently did is we actually look at the reinforced learning from human preference process. This is a very critical component of building large language models. So we use this question called, where are you from? Which is very benign. And we then ask AI systems to tell us, I'm from country X, So the country could be, I'm from Canada, I'm from US, I'm from China, I'm from Russia. And then we can use like reward model in RHF to give a score of how good is this response. And basically, as you can see from this specific map visualization, existing reward models tend to give very high reward to English-speaking Western countries and a lower reward to countries in the Middle East and Africa. And the recommendation here is to think about whether there is a human in the loop. People who are representative of the population that the large language model is meant to serve at every stage of the research process. We could also think about AI in the loop and the human in charge perspective, where human experts are in control of the interaction and can accept or reject suggestions from large language models. The last dimension I want to mention here is called reproducibility. I think making research reproducible is quite challenging. And it's going to be more challenging with the intervention of large language models because those models tend to give you a very black box kind of understanding. And a lot of times, social scientists care about the mechanisms, care about the process. So it's really unclear on how we can assign meanings to those billions of parameters in large language models. So the recommendation here is that we could think about how to complement large language models with very traditional and classic lexicon analysis. And also thinking about using large language models as a reproducible tool, acknowledge and incorporate the stochastic nature of large language model output into analysis, and maybe like rely on new mechanisms or design to enable transparency here. There are also lots of other dimensions I didn't mention today, such as privacy and many, many others. But basically, moving forward, how we could actually achieve the full potential of large language model in computational social science. I think we need to invest in keystone data sets that can represent populations and the social construct of interest, that can link to societally or socially important outcomes. We can also steer large language models for better human-AI interaction. A lot of the social technical systems and the interventions can actually really benefit a lot if we could integrate large language models into the process. And this process also relies on a lot of the open science or interdisciplinary collaboration with researchers, not only in social science or computer science, but also in many, many other research fields. This is all what I want to share today. Thank you for listening. Happy to take any questions.
Okay, thank you very much, Dee. So it's very, very insightful and triggering talk. I guess that there are a lot of questions. So I will take my advantage as a host. So it's a quick question about a little bit of technique. So about the second study, the feedback system. So because that you mentioned that you have some experts or critics that give feedbacks, and then you can just refine the generation process, right? So my question is how actually technically that how actually you can do this? Will actually you refine you fine tune the model or just change the prompts according to the feedback? And
Yeah.
I'm sure, yeah.
Okay, yeah, happy to explain this further. So first, the constitutional AI is a framework that Anthropic introduced to like make models more harmless and more helpful. So the key idea is that whenever we want AI to like generate a response or we want to select a response, we are going to give them a few kind of principles or something like a constitution. And then we are going to use all the constitution to look at the current response to see whether the response is good or not. So imagine in your constitution, you could see like any response, they need to be very polite. They should not discriminate against anyone. So if there are those two principles, then in the constitutional AI framework, any response needs to pass those. So this is the traditional constitutional AI for general AI framework. So here, what we do is that we build this constitutional AI framework for therapy or for building AI patient here. So this feedback, we want a natural language feedback because domain experts, they are experts in psychotherapy, but they are not experts in like AI. So they cannot change like parameters, etc. So we ask them to just tell us like from a natural language perspective, if you look at this conversation, is this AI patient, is this like patient like typical of any patient you run into? And then the expert will just like talk about their experience. They were like, this is not what it looked like. And then we have an algorithm to convert this natural language into these principles. And then once you have those principles in your constitution, we could then update the original constitution with this like a new constitution. And any kind of future AI response will need to go through that new constitution. This is how we set it up.
Okay, thank you very much. So a question from Tony.
Oh, yeah. Thank you, Didi, for the fascinating talk. And obviously, as a lifetime social scientist, your talk is touching our nerves in the sense that in part one, you talk about measurement, the relevance of AI tools for measurement. And without measurement, there's no science, nor social science. So you are projecting for us a few potential paradigm shift in how we do science is really fundamental. So my number $1 million question is, to what extent can this new frontier of using large language models, especially when in the future you can extend to multimodal data, is going to so-called replace what we have done, accumulated over 100 years of empirical social science? Is it going to be complementary or going to be displacive, substitutive? And one of your early slides indicated the responsiveness of general large language models to fine-tuning. To me, it implies localization of a general model, train it with specialized data to make it smarter to address targeted questions. And I would suppose that would be an opportunity for human and AI collaboration instead of a zero-sum game, one replacing the other. Based on your knowledge of fine-tuning and doing so many different experimentation and evaluation, what is your current assessment of how much is it going to be complementary, or the past is already gone? Large language model is going to take over much of the fundamental part of social science.
Yeah, great question. I think this is really like a $1 million question. Let me kind of unpack it into a few dimensions. First, from a measurement perspective, I think this trend is unstoppable. So basically, this new wave of large language models, they are going to introduce a lot of scalable tools to help social science research. So previously, we spent a lot of time developing like coding manuals, and we build a like classifier, etc., etc. Although I think I showed you that this kind of fine-tuned models tend to have bigger numbers from an accuracy perspective. But this part, you need to train the model. You need to have your own GPUs. You need to train the model. Versus on this red box part, those are zero-shot performance. That is, you simply ask it without giving it any kind of coding or insights. So I think, and also models are getting more and more accurate. So moving forward, I think using large language models is going to be a very important tool just like how we use use all sorts of like tools that we have. I think that this is a trend that's going to be very beneficial for social science research. Second is something I didn't mention today, but we recently have a paper called Can Large Language Models Generate Novel Research Ideas? So the key idea is that if AI or large language models can not only help with measurement, but also help us with idea brainstorm. Since we can only read one book in 1 week, but models can read 10 books probably in 10 minutes. So in this way, they might be exposed to a lot of like new concepts or just like a lot of content. So when we are thinking about how to make connections between certain social constructs, it might be possible that models can actually see more information compared to us. So you can imagine that there may be a human AI collaboration to do even research together in this fashion. So in this way, I think human creativity, innovation will be empowered by those models. And my third aspect is actually from an inequality perspective. I think knowledge production sometimes are limited to certain countries, or because it may also rely on economics development. So certain regions may have more research compared to others, like in terms of studying the local population's behavior, et cetera, et cetera. And now, because those models are trained with internet data, they know a lot about not only just certain type of countries, but many other countries. So if researchers can actually utilize the knowledge there in these models, then we can actually study many low resource contexts better. Previously, if we want to understand a specific low resource context, such a just like use Indonesia as one example, then maybe we need to work with native speakers to do all this kind of research. But now GPT-4 can understand the native language well. And if we are going to gather a lot of cultural or other kind of social norm knowledge, maybe we will have a faster kind of understanding there. So those are the promise of large language models. Of course, I think we need experts, we need people in this process, just because like developing theories or developing insights are not something that, okay, here are just like the text, and then we need a very rigorous process to make connections and also to validate, to do a lot of the validity check to make sure that such knowledge or such findings are something that can stay for some time. So I think this kind of theory, construction, knowledge creation are still needed, especially from a kind of like human AI collaboration fashion. So this is a really big space. I'm very optimistic that these large language models can offer more tools and resources for us to do better research in this domain.
Very good. Thank you. Can you refer back to your first point, amplify a little bit? Are you saying that training will help model performance seems by a lot according to your data, but you also seem to say that it's costly, a lot of input?
Yes.
My original question was whether that is indeed an opportunity to persuade social science that don't feel so threatened. There are room for improvement using your expert knowledge and prior knowledge in the literature to significantly improve the tool and make it incorporated into our part of our research toolkit.
Yes. So for that part, I think there is a cost-benefit analysis. So this table, I agree with your interpretation. That is, if I only care about the number here, then you could use human insights and label 1,000 data points, and you have a more accurate emotion detector. So this is for sure. But you need to spend time to do like 1,000 data points annotation. You need to train a model here versus this red box here. Although the number look really like maybe right now on my current screen, it look really different. But it's easy to use. You only need to ask one simple question. And I'm here showing the zero shot fashion, but you could also make it like a few shot where you give it a few examples. So let's just take this ideology as one example, 64.8. If you think about the cost of annotating 1,000 data points by working with researchers versus just ask GPT-4 to give the prediction, which is only one sentence, only take 1 minute, versus this one probably take 1 month. And that's 64.8 versus 60 here. So there is a trade-off here. So I think from one dimension, as you mentioned, we could leverage human insights to push this further, and I totally agree on that. I just want to point out that by the end of the day, there may be a cost benefit analysis. And also this red box is getting more and more advanced over time. So when we benchmark GPT-4, this is already like earlier this year. So right now, models may do much better compared to the numbers I reported here. So there is an analysis or a trade-off here.
Great, thanks.
Okay, thank you. Eric?
Professor Tam had $1 million question. I think I'll be lucky to formulate a $4 question, but let me try. I think, there's so many thoughts going through my mind as I listen to this. I mean, first, thank you for the presentation. It really is fascinating and much to think about. I guess one thing I'm wondering about, or the main thing I'm wondering about really is the human AI kind of interaction. And maybe my larger point is that we seem to be, for the large part, I mean, we're looking both ways. We're kind of looking at kind of the computational aspects of human behavior, of social kind of behavior, of social knowledge, etc. And I'm wondering whether we should, kind of as a society, be thinking equally or maybe even more, prioritizing more, thinking about the social science of computation as opposed to the computation of social science. And it just has to do with that kind of interface between sort of the machine and the person, right? And who's guiding whom. And I was, as you were going through some of your examples, I was thinking, for example, this notion of teaching is one term that you use, but then persuasion was another term that you used, right? And then control or coercion is maybe a next step in that, right? That how, if we're trying to guide, I mean, a benign interpretation has to do with how we guide the way we train our machine to guide the way the human is thinking. And in the most benign way, it's sort of making them to be a more competent therapist, making them to be a more, clever person, more useful person. But as we go to sort of persuade, well, then it's even in the teaching, of course, there is some implicit set of criterion for how how we're measuring the human, right? As we go to persuade, that sort of latent or passive benchmark is made even more overt, right? Well, we're persuading. So this person is not thinking quite the right way. We need to sort of begin to experiment. We can go into large text research to sort of understand why it is this person's behavior or thinking is wrong, right? And how we can intervene, right? So there's the measuring and then the intervention, and then then that can be slid along further and further. And I'll maybe stop with then one last observation, which is just that one of the things that's been on my mind a lot recently, just as I've been sort of not even engaging with the world, but just trying to sort of understand what's going on in the world. Here in the United States, places I see, well, just in Korea right now, I've been having a lot of interactions with people in Korea and about Korea, and also in the UK. I mean, in many societies right now, there's an increasing polarization. It's a kind of political polarization or a cultural polarization. So I guess another aspect I'm thinking about is how, I mean, if there are different camps, right? And my camp wants to teach, or at least, or maybe persuade, or at least, what happens when these different sort of paradigmatic machineries go at each other, right? And where does that leave us? And so again, that kind of brings me back to my initial point, which is that it seems to me that putting a kind of the human part in the front and thinking about the social science of and the humanities of computation as opposed to the reverse, or at least in addition. So maybe that's not even a $4 question, but maybe it's $2 or $3.14. Might as well make it pi, right? $3.14.
Yeah, I mean, I love your question, Eric. I think it's also $1 million question. So there are a few things. First, I mean, I just want to acknowledge it very explicitly. So my perspective is probably more on the computation of social behaviors. And I understand that a lot of you all care about social science rather than on the computation side. So I think if we think about computational social science, I probably personally have a bias against the computation, and you have a favor towards science or social there. So every of us have our favorite component of computational social science. So this is like my positionality statement. Going back to your question, first, I think it's true. So we are building AI to make them more capable, more aligned with human preference, human values. On the other side, AI are there. They are also changing how we behave, either by design or just we are influenced unconsciously by it. So this is actually a kind of co-evolvement process. It's not like one is only adapt to another, but it's a co-adaptation that's happening. So this is like one broader phenomenon I think we are going through. Second is, if I think about a lot of the societal issues like polarization you mentioned in multiple countries right now, this is why, my second part, I actually talk about intervention. It wasn't in the part of the story, but as a person who look at the merriment, I feel like merriment is only one step of the story. Merriment only tells us something about data, something there, but you need a proactive to change, to influence or to make a change. And this is where intervention comes in. I didn't show the example I have, but recently people actually have been using this kind of framework I shared to teach the general public how to better talk to each other, how to better listen to opinions from someone who have a different political ideology compared to them, to invite a group of people to comment or to express their perspectives on some controversial topics. I think this large language model or this kind of AI-based systems can be a leverage for building more, I guess, talk among different type of participants. And maybe this won't solve the final kind of polarization issues, but it's one step of ensure all of us learn how to better communicate with others, because a lot of the controversial debate or discussions actually didn't go into this constructive stage. they often just get into heated fight or just like hate all sorts of things because of the language use, because many of us don't have the skills. So the intervention part that I mentioned today, I really hope that there could be some change we could introduce by utilizing AI, because they are going to be this like kind of like very immersive kind of learning environment. If all of us could learn how to better express our opinions without like offending others in the conversation, or how to talk to someone who has a different like perspectives and hear them, etc. So I think that's one like kind of like baby step of building something there. This is like my perspective. Yeah, happy to like elaborate on any specific aspect.
Thank you.
Okay, thank you very much. The next question from Tang Wei.
Can you hear me? Can you hear me?
Yes.
Yeah.
Okay, thank you. Thanks for the sharing, and I really enjoy it. And I'm quite intrigued by the use of LLM for annotation or to say classification. And here's my question. Regarding the research you have shared in today's talk, I'd like to know how many of categories that are there in your labels when you are using the LLM for classification. And in social science, there are cases that there are usually such kind of cases that there are like more than 10 or even 20 categories of labels in the classification task. And I'd like to know, do you have any recommendations for such kind of classification task with more than like 10 categories? And that will be a very practical and detailed question. And thank you.
Yeah, so first for the classification task, we look at some of the tasks, they have like 2 or 3 labels, like categories. Some of them have 5 or 6. The one that has the most is actually like event type classification. So those tasks tend to have over 30 labels. So I think like yours around like 10-ish is actually not on the extreme side. So the commonly used approach is to, instead of letting the model do a specific output, you basically enforce a JSON format. So for each of the label, you are going to output whether it's 0 or 1. So this is one approach. And the second approach is that especially for social signals, sometimes some of those may share a broader category. So you could do it in a hierarchical fashion. First, let it decide which broader category it is like picking up. And then among the specific category and which subcategory get applied. So you can basically do this kind of like 2-staged prediction as well. Yeah, hope that helps.
Oh, thank you. Thank you. That would be very inspiring. Thank you.
Okay, that's great. I guess that we have to stop here because it's very innate in California. So let's thank you Professor Yang, and thank you all for coming for today. Okay.
Thank you for the great questions.
Yeah.
Thank you. I hope to see you in person someday.
Yeah.
Yes,
In the near
likewise.
future.
So do let us know so if next time you're in Hong Kong. Okay.
Okay, sounds good.
Yeah.
Okay. Bye-bye.
Bye.
Bye. Bye. See you.